Okay, so let's look at a couple examples now using the information that we've just talked about. So at the bottom of your notes here, we've got 6 examples. Okay, so let's start with number 1. It says find x. All right, so let's look at the picture. Let's find x. Well, x is right there. Now, here's the key thing. The vertex of that angle is on the circle. So we know that this is going to be half the measure of the intercepted arc. Now, if we take this, if I trace out my angle, I'm going to hit the circle in 2 places, here, and then I'm also going to hit here. The arc between those is the intercepted arc, and that's 146. So if it's a central angle, it's the same as the arc. But if it's inscribed, if the vertex is on the circle, it's going to be half of the arc. So half of 146, all we have to do is 146 divided by 2, and we get x is equal to 73. That's it. Okay, look at number 2. Find x. All right, x degrees, that's this angle right here. Where's the vertex? The vertex is on the circle. Now, where does this hit? Where does the angle hit the circle? It hits it here. And then it also hits it back at the vertex because this is a tangent here. So the arc is going to be all of this. The arc measures 110. So the inscribed angle is half of 110. So we take 110, we divide by 2, and we get x is equal to 55. Okay, 55. And you can say 55 degrees, that's also fine. Okay, how about number 3? Now this time, x is here. Again, it's inscribed. If we trace this out, the angle hits the circle here, and the angle hits the circle here. So here's the arc. Well, if you want to find the angle measure, you need to know the measure of the intercepted arc. They don't give it to us, but that doesn't matter. We can still find it because notice that they give you other arc measures. They give you that this is 98, and then they give you that this is 150, and you know that the total of all the arc measures in a circle is always 360 degrees. So let's take the 98, let's add it to the 150. Okay, so on the side here, I'll do it up here, 150 plus 98 is 248 degrees. Now we need to find out what's left over. We can do that because we know that the total is 360, so let's subtract 360 minus 248, and we get 112 degrees. Okay, so we know that this is 112 right here. If the vertex is on the circle, it's half the measure of the intercepted arc. So take 112 divided by 2, and we get x is equal to 56. Right, that's it. So sometimes you have to find pieces before you can find the answer. You're going to see that a lot with circle problems. Okay, let's go down here to number 4. Find x and y. Okay, so now they're asking us to find different pieces here. Well, let's see. The only number that we know is 31. 31 degrees is this angle. It's inscribed. The vertex is on the circle. Here's the vertex. Well, let's look at where that hits the circle. If we trace it out, this angle, it's going to intersect here and here. So the intercepted arc, is going to be x. Well, you know that the inscribed angle 31 is half of x. So to figure out x, what you do, instead of dividing by 2, we're working backwards. We're going to multiply by 2. 31 times 2, which is 62 degrees. So x is 62. But we also need to find the y value. Well, if you look at y, the vertex for angle y is right here. There's the angle. Okay, I can do a double arc there. That's at the center of the circle. Now if I trace out, where does the angle hit the circle? Here, here. Same two places. So again, it's a 62-degree arc, but now this is for a central angle measure. Yesterday we talked about central angle is the same as the arc measure. So if the arc measures 62 degrees, the central angle is also 62 degrees. Okay, so x is 62, y is also equal to 62. Okay, there's our answer. Number 5, find x. All right, this time, let's see, x, that's an arc measure. The number that we are given, 137, that's an angle. Where's the angle? The vertex is on the circle. So if you trace this out, where does 137, where does it hit the circle? Here. And then the other place that it hits is back here at the vertex. Central angle is the same as the arc, but if the vertex is on the circle, it is half of this arc. So if you know the angle, we're going to work backwards. Let's take 137 and we're going to double it, times 2. Now that gives us 274 degrees. That's the arc measure. That's not the answer though. What do they ask for? They say find x. Well, x is what's left of your circle. You know that all the arc measures have to add up to 360. So if this piece is 274, let's do 360 minus 274, and we'll subtract here, so 10 minus 4 is 6. We're going to borrow, we get 15 minus 7 is 8, 86 degrees. So x is equal to 86. So we just go piece by piece. Oh, the last one, number 6. This looks really confusing, but let's just go step by step. We do one piece at a time and let the problem work itself out for us. You have a triangle inscribed in the circle. You have 50 degrees, we have 60 degrees, and we have a missing angle, which actually we can figure that out because you know that all three angles of a triangle always add up to 180 degrees. The triangle is 180. So if you take 50 plus 60, that adds up to 110. If we do 180 minus 110, we'll get 70. So this is 70 degrees. Okay? Now, you have your choice of whether you want to find x, y, or z first. Let's say you want to find x. X is this arc. Well, you have three angles inside the circle. Which angle is intercepting this arc, x? So if you go from the points, the endpoints of the arc, let's trace it back. Which angle's creating this arc measure? It's the 60 right here. So if the vertex is on the circle, the inscribed angle is half of the arc. So 60 is half of x. Well, that means we have to do 60 times 2. We're working backwards to get the arc. So that's 120 degrees. So x is 120. To get the y value, well, again, let's take the angle measures, the inscribed angles. Let's take 70, trace it out, here, and here. So that gives you the y. So if that's 70, again, you have to work backwards. 70 is half of y. That means y is 2 times 70, which is 140 degrees. Now to get z, you've got two ways to go here. Well, you know that the arc's 120 and 140. That adds up to 260. Z is whatever's left over out of 360. You could do that. Or you could just say, you know what? This 50-degree angle is creating arc Z. If I trace out the 50 here and here, there's arc Z. The vertex, the angle, when the vertex is on the center, when the vertex is on the circle, it's half of the arc measure. So 50 is half of z. That means z is 50 times 2, which is 100. Okay, and that's it. Now, here's what we're going to do. You have an assignment. It's a worksheet that says Circles Day 2 on it. I'm going to go on the back. I'm going to do a couple more examples. Now, if you want to turn the notes off and stop, you can go right ahead. But if you're interested, I'll work a couple problems here for you. Some of these can be a little bit tricky, and I want to explain a couple things here. For example, let's say we take a look at 27. Okay, let's take a look at 27. So they give you a couple of things here. We're going to try to find x. They give you that this angle here is 7x minus 10 degrees, and then this arc measure is 120. Now the 7x minus 10, the vertex is on the circle, so it's half the intercepted arc. Where's the arc? It's the 120. It's right there. So we know that 7x minus 10 is going to be half of 120. So if we take 120 and we divide by 2, we get 60. 7x minus 10 is 60 degrees. Those are the same. 7x minus 10 is 60. I don't need the degree measure. And then I solve it. Plus 10 plus 10. We get 7x equals 70. Oh, this works out nicely. Divide by 7, divide by 7. X equals 10. Okay, and that's the answer. Okay, so if you're dealing with variable expressions like 7x minus 10, nothing changes. You know, you're doing the exact same thing. You do the exact same thing. Okay, we'll do one more example here. Let's take a look at, let's do number 20. Okay, let me move over here to number 20. Find the measure of arc FGH. Let me trace that. F to G to H. All right, that's a big arc. That's a major arc right there. That's going to be more than 180. Now look at the angle that's going to create that arc right here. So its angle A is going to intercept this major arc. Now one thing that we talked about, there's a special relationship. Notice you have a quadrilateral inscribed in the circle. Opposite angles of an inscribed quadrilateral are supplementary. They add up to 180. Okay, so that means that 21x minus 2 plus 38x plus 5 equals 180, and then you solve it. Okay, and I'm going to let you solve it. You'd have to plug it back in, and remember you have to find the measure of the arc here. But I'm going to let you do that, and that is the end of our lesson.